Currently we're looking through a single lens of a pair of AR glasses. Now, augmented reality is different to virtual reality because it blends the digital world, so in this case the engine block, which we can take apart and rotate, while at the same time in the physical world I can pick up this pen, write notes and potentially discuss to colleagues why a particular cylinder might be misfiring. AR is still being defined, and I'm going to talk about two emerging different types: everywhere and directed. Everywhere AR, as the name suggests, is AR that's always with you and is displayed everywhere. So for example, you might meet someone but you can't quite remember their name, so the screen renders it above the head to remind you they're called Bob. Directed AR works differently. It's directed at a specific space, so in this case a table, and you can have various people around that table looking at the AR image that is being drawn there. An example of this is Chewie and C-3PO playing holochess. Now, the reason to define these two types of AR is they can use two different types of AR technology. Everywhere AR, the digital images are rendered close to the eye, and any 3D objects in the physical world are rendered afterwards. Whereas directed AR, actually any 3D objects are in front, and then afterwards, on a predetermined space, the augmented reality images are rendered. Now, this actually has some important properties, and the advantages of a predetermined space I'll discuss now. The first advantage is setup. Now, if we go back to our table example, with someone standing round it, it actually has quite a subtle but important point. The first is this person knows where they're meant to be looking. Now, this seems quite trivial, but for people who've not used AR and VR before, then this gives them a grounding of what they should be doing. In addition to that, the area can tell the hardware what it should be focusing for. So this might be a pattern around the edge, which would be a passive indicator, or potentially something with an active element, such as infrared LEDs. Now, because of this relationship, this means the setup can be done beforehand because the AR hardware knows what it's looking for, and there isn't any manual setup required by the person. Setup then is linked to our second advantage, which is cost. Now, if you think about it, everywhere AR requires quite a lot of power to work out where it is in a room. Now, that means it's probably going to need more CPU power. It's going to need more sensors. This has a knock-on effect to battery life, and then a financial cost as well. Directed AR doesn't quite have the same problem. Because the space is helping it guide to where it should be, more of the processing power can be used for rendering the objects. And this is why everywhere AR typically is thousands of dollars, whereas directed AR is hundreds. The third advantage is the blank canvas. Now, if we go back to our example of the table, imagine you're playing a game of tic-tac-toe. We've discussed how important it is for the player to understand the space and also the AR hardware, but there is someone else who needs to understand it too, and that's the designer of the game here. If you start removing squares, then the whole game changes. The designer has to be aware of what they're designing for. Now, here we've only discussed a 3x3 grid, but imagine this gets even more complicated because it's in a 3D space. And this is why the designer really needs to know what blank canvas are they working on. So directed AR has three great advantages. One is setup. Two is cost. And three, there is a known blank canvas. And because of this, directed AR is more likely to become mainstream before everywhere AR.